Let's continue our study of repetition and while statements by implementing a game of craps. Here's the problem statement. Write a program to play a modified version of craps. The user will roll 2 6-sided dice. They lose if the sum of the digits is 7 or 11. That's called craps. They win if the sum of the digits is 2, 3, or 12. And they roll again if the sum of the digits is 4, 5, 6, 8, 9, or 10. The first thing we want to do is design our test data. Now this gets a little bit tricky because of the randomness here. So it's really hard to tell if something is really random. Because we're going to use math.random, the random number generator that's built into Java, we're not going to worry about whether it's random or not. We're going to assume it's doing its job. But we do want to make sure that both 1 and 6 appear, because that will help us identify an off by 1 bug, a very common problem as we've discovered. The other thing is we want to make sure that 0 and 7 don't appear. Now I think we'll notice them if they show up. One way to do this is to make sure that all 6 rolls appear at least once. That's a way of checking to make sure your program is doing what it should. The other thing we want to do is to make sure that the correct thing is done with each option. Now the only way we can be sure that we're getting the correct thing with each option is to make sure that each option is done. So we're going to need to keep track of which options have been done. Let me show you how I design this into a program. So here's our craps program. I've created the shell for it, same as usual. And what I've done is created placeholders to make sure that all 6 of these rolls are seen and that all of these combinations are seen. I've also put the correct answer in them. That way I will be able to check them when we encounter them when we're running our final program and make sure that we're getting all of our data. So to get started, as you've seen, I went to Eclipse, created a project, created a class, created a main program. The next thing I want to do is outline the code with comments. So we know we're going to have to repeat. So I'm going to put in while true. Now, true may or may not be what we end up with in that while loop, but this is a way of keeping Eclipse quiet while we decide what we want to do with our while loop. Inside the loop, we're going to roll the dice. Notice this needs to be inside the loop because we want it to be repeated, and things that are repeated are inside the loop. And then determine the fate of the roll. So those are the 2 cases, the 2 things we need to implement. And that gives us a basic structure to the program. We could even put a comment in our while loop. Roll until you win or lose the game. Now let's talk about rolling the dice. The math.random method returns a random double between 0.0 inclusive and 1.0 exclusive. Now, these are standard computer science-y ways of talking about these values. Let me explain in detail what they mean. When we say 0.0 is inclusive, we mean that 0.0 can actually be returned from the random number generator. When we say 1.0 is exclusive, we mean that anything up to 0.99999 can be returned, but 1.0 cannot. This has important consequences in our decisions about data. So the first thing you probably think we should do is multiply by 6 and truncate. Well, let's take a look at what that will actually do. Now, I've organized this into a table, and that's a really good way to organize these computations. So what I'm doing is looking at the boundaries. At 0.0, the lowest number that can be returned by math.random, at 0.5, which is the middle, and at 0.99999. That's the biggest number that can be returned by math.random. If we multiply by 6, we'll get 0.0, 3.0, and 5.999. Now, when we truncate that to an integer, what we get is 0, 3, and 5. Now, when you look at that table, you'll see those are not the outcomes we want from dice. Dice should be between 1 and 6. So what we need to do is improve our strategy. After we truncate to an integer, we need to add 1. Creating tables like this is really a useful way to think through these calculations before you write them down in code. In fact, you can even put this table in your code as a comment. Now that may seem really excessive, But think about it from the perspective of being a professional, as I know some of you will be someday. What you want people to think when they're reading your code is, oh my God, this code was written by somebody who's brilliant and did a wonderful job. Think about how detail-oriented and how perfect they will know your code is when they see that. Now, I'm not saying you always have to do things like that in a Java 1 class, but it is important to think about the professional persona that you eventually want to put forward as a programmer, if in fact you're going to make a living doing this. Well, we're now ready to write the code. So, for rolling our dice, we're going to take math.random, multiply by 6.0, and add 1. Remember, we also truncated. We might want to think about where our parentheses should be. Our truncation should occur after math.random has been multiplied by 6. If we don't put these parentheses in here, our code won't work, because remember, casts have very high precedence. Well, if you truncate math.random using a cast, you'll always get 0. That is not going to be a very interesting result. So now that we have this, we want to check and make sure it works. So let's just print it out. Now I've got an infinite loop here, so we're going to have to stop the program from running, and that's fine. But it is a good way to test the data. I'm going to give us a little bit more space, because once an infinite loop gets going, it's going to go really fast. Here we go. Okay, so what we want to make sure is that we've seen all the numbers 1 through 6. I see a 1, a 2, a 3, a 4, a 5, and a 6. Okay, so we have all of our numbers. I'm not seeing any 0s and 7s, so that means this is working correctly. Now remember, we do want to roll 2 dice. So let's put this in now. There's no reason to leave this system out print line in the code, unless you think it's something the user would want to see. And I think this is something the user wants to see. So let's put in some comments to make it more clear. Your first roll was, and then roll 1. And then we can copy and paste this code. And we'll create a roll 2. Of course, we want to make sure that we change the comment to the users. So your first roll was this, your second roll was this. Let's run the program again, see what things look like now. Okay, so that's looking pretty good. Still an infinite loop, so I had to stop it with a little red button. So let's talk a little bit about the technique that I used to create that code. It's a really good technique to remember. It can save you so many hours of debugging and randomly trying things. What I did was I checked the formulas at the boundary and in the middle. Now this is not foolproof. Things can still go wrong with formulas, but this works a tremendous number of times and is really helpful. You can include the table in the code as comments, as I mentioned, although I haven't done that. Now the second thing we have to consider is what should our second control structure be. When we go and read through the problem statement again, you'll say, if you get a 7 or 11, you lose. If you get a 2, a 3, or a 12, you win. The presence of all those ifs is a hint that it should be a conditional statement. Now we've got 3 different things that can happen. We can win, we can lose, or we can roll again. It's really important to think about the organization of this if statement. So one way that you could do it is in numerical order. Look at rolling a 2 first, then a 3, then a 4, then a 5. And in fact, that's a good order to do. But you could also consider whether doing it by outcome might be a good idea. So maybe you want to put all the winning cases together and then all the losing cases and then all the roll again cases. Those are both possibilities. My preference is to do it in numerical order. The reason is that it's easier to check and to make sure that you have all of the cases there. When you start getting them out of order, it's a little harder to do. Now, we can copy and paste some code to get this done a little bit more efficiently. So let's go to the code. So here we are, back in Eclipse. Now we know we're going to sum our two rolls, so I'll call that roll. Now you might think about whether you want to display that to the user or not. You certainly could, but if you think about a craps game, it's usually played at a table with dice, and the users add the dice together themselves. So maybe this is more like the real game. If you want to put it in, it's fine, of course. So if roll equals 2, remember 2 was a winner, so we did system out print line, you won, with an exclamation point to give them a little extra reward. Now let's think about how we're going to break out of that while loop. We can't look for roll being 2 here, because if we do that, we've got to put together several of them, and we don't have that technique yet. So we're going to have to learn a little different technique. What I'm going to do is use a return. The return allows you to exit the while loop, because remember, the return will exit the main program. So it's kind of a clever little trick that we can use in this particular case. Now, we've got a lot of other cases to work through here. And let's move our comment up to the right place. So let's write one example. If roll equals 3, well, that's another winner. So we're going to copy this and put it in there. Now I'm going to copy this part and paste it down. So here is 4, 5, 6, 7, 8, 9, 10, 11, 12. Lots of cases. So let's go back and renumber them right now. So there's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now Eclipse is going crazy with a bunch of complaints over things that don't look wrong to me. When that happens, you want to go back up to the top and see if something went wrong right at the top. Ah, I see what went wrong. I forgot to put an if after my else. Well, that's unfortunate that I copied that 12 times, but let's go and fix it. Incidentally, the best way to find mistakes in code is just by reading very, very carefully. So don't start randomly substituting things. Stop, think, read, analyze. Those are the skills you need to get code to behave a little bit better. And of course, I should have made sure that this was compiling before I copied it so many times. Okay, so now that Eclipse is happy, let's go through and implement the right cases. We're supposed to win with a 2, a 3, or a 12. Well, right now we're winning with everything. So 4 was a roll again. But remember, we don't want to return then because we don't want to leave the loop at that point. 5 was a roll again. And again, we don't want to return. 6 was a roll again. With no return. Now 7 is a you lost, not a you won. And that one does need a return. 8 is roll again. And of course without a return. 9 is roll again. Without a return. 10 is roll again. Without a return. 11 is a loser. And that one will need a return. And 12 is a winner. So it looks like we've got all of our cases in there. So now we're ready to run our program. Our first roll was 1 and 4, so that's case 4. Now I'm going to go to our test data and cross off the cases that we've seen. So we've seen that, and we've seen rolls of 1 and 4. Then we see we had a roll of 2 and 3, which is a roll of 5. So 2 and 3 are done too, just keeping track of what cases we've actually seen. And then we have a roll of 2 and 1. So that's a win, that's correct, and 2 and 1, we had already seen that roll on the dice. Now all we can do is keep playing this program until we've seen all the possibilities. We want to be especially careful to see 2 and 12, because remember, those are the boundary conditions. That's a place where there are a lot of errors and a lot of problems. Okay, so our first roll was a 6 and 3. And we can see that it did roll again. That gives us our 6 also. Then we had a 2 and 4, so that's the 6th case. And it did roll again. We had a 4 and 1. Now we've had that case before. And a 5 from the 3 and 2. We've had that case before. We've got 3 and 3. We've had that case. 2 and 2. We've had that case. 2 and 6. There's something new. 2 and 6 is case 8. And it's still rolling. And then 4 and 2 is case 6. Here we have 5 and 2, and we lost. By the way, that's also our 5. So we don't need to look for the individual dice anymore. We haven't seen any illegal dice. We're seeing all the values. That looks like it's working well. Now we notice the cases we haven't seen are 2, 10, and 11, and 12. If you know anything about probability and statistics, you'll probably recognize that those are some of the least frequent rolls. So it's not surprising that we're having trouble getting those. Running the program again. So 1 and 4 again. There's a 10. There's one of the cases we were looking for. And it did roll again. Then we have a 3 and 1. Rolling again. 6 and 1, we lost right away. 1 and 2, we won right away. 3 and 5, 1 and 2. 5 and 5, 3 and 6, 5 and 2. All we can do is play this program over and over until we've seen all the cases. So we've now seen our 1 and 1 win, but we haven't seen 11 or 12. So there's an 11, and not surprisingly, one of the least common ones is 12. Didn't get it that time, didn't get it that time, didn't get it that time, or that time, or that time, or that time. Because 12 is a win, we know we only need to check the last one. Now, I'm not going to give up on this until I've seen that 12. The probability of a 12 is relatively small. And there we go. We finally got it. The reason that it's important not to give up is remember that these boundary off by 1 conditions are exactly the kind of errors that occur in programs. So you really don't want to give up on those, even if you have to run the program several times, as we did. To recap the program, first, we took repeated turns using a loop, a while loop. We had 2 quitting conditions, winning and losing, and those presented a problem with our current knowledge. And so what we had to do was return out of the loop to get past it. So it's a very strange idea to make an infinite loop on purpose in a program and then exit the program when necessary. But it did work in this case. So keep programming.